smell something? I smell packets. We're going to talk about sniffers. Now, as far as where we are in the Certified Ethical Hacker, this can be in a variety of places. This could be reconnaissance data at the very beginning. You could be capturing packets there. It could be privilege escalation, listening on the wire for clear text passwords that were flowing across. It's not really the browsing the system, although it could be browsing the network of that organization. As far as maintaining control, I don't know that sniffing can help you maintain control, but more information is a good thing. So we kind of flow around sniffers. And when we talk about sniffers, you need to understand what they are, how they work, the mechanical portion of it, because there is a physicality to this. And you also need to know about the technology of it and understanding active and passive sniffing. And then what we'll do is, once we understand how to use the tool, and the tool is Wireshark. You can use other network monitors, but Wireshark is the one that we discuss here and the one that the EC Council expects you to know for your exam. But after that, then what we want to do is we want to say, okay, with this data, what could we do? So we flip over to the evil side and start talking about ARP spoofing, redirection, DNS, IP spoofing, little HTTP sniffing, and showing how all this stuff works together. Generically, a sniffer is a network card listening to all packets. That's called promiscuous mode. Normally what happens on our network cards when they're physically attached to the network, all the bits are flying across the network, especially in a contention-based Ethernet network. They're flying across the network, and the bits come up to the card, and the thing that is introduced to them is the MAC address of this particular data packet that's coming across. This frame that's coming across. Sorry, it's not a packet. It's a frame at that point that flows across. And that frame gets to your network card, and your network card looks at it and says, there are one of two options here. If it's a broadcast frame, I'll take it. Or if it's a directed to my network MAC address, I'll take it. Everything else, as soon as it realizes that it's not its MAC address, that it's not a broadcast, it should let it go. That's if it's going across that wire. Promiscuous mode says, I'll take everything that comes my way. That's why it's sniffing. You're going to need a software program or a hardware device. We use a combination of hardware and software that's built into the operating system, and that also that we download the wireless, we download Wireshark. But there are some tools like Fluke and a whole bunch of others out there that do all of this stuff with basically a handheld meter. It does it all in one. It's a single device. What we're going to do is we're going to have those tools, and we're going to listen on the network. We can listen at any layer. We are always listening a layer 2 and capturing that information, and then we're examining as it gets up in there. We could look at the raw hex of it, or we could resolve it, translate it, and make it easier to read. Now let's be clear, we're not intercepting or altering. All we're doing is catching the packets as they grow across the wire. We're not taking them away from anybody else, and we're not changing them in what we're doing. Now that's in the evil part. Okay, here's the security context of it. Here's the problem that we as penetration testers are trying to solve. Clear text happens on networks. We just don't want that clear text information to be very valuable so that an attacker could use that information or abuse that information. Now remember, if you can run a sniffer, so can everyone else. There are tools out there that will detect a network card in promiscuous mode. They are specialized. So in my first course, when I sat down and listened to Stephen Northcutt of the SANS organization discuss, this was kind of far back, he said, you should be reading it in hex. You should be reading the raw packets. You should be able to understand it that way. You should look at those packets flowing across that wire and get it. And I went, yeah, I mean, you could, but then you'd spend all your time doing the translations in your head. And I said, why not read it in a form that works for me as a human being, you know, and have some interface interpret that or translate that for me? He said, well, what happens if that interpreter is corrupt? Or what happens if that interpreter doesn't know what is being offered to it? I said, you got a point. I said, but then at that point, what I would say is, for the bang for the buck, I'm looking at all my packets, and when they're misinterpreted, I would recognize that in the interface because there would be errors, and then I would go down to the hex level and look at it there. 99.9% of the time, the interface is going to translate it correctly. And he said, well, what happens about that 0.1%? I said, I can't be worried about that. I mean, I just have to go ahead and fight the battles that I can win. And he said, well, but you could just learn heck looking at it that way, and it should be fine for you. I said, well, I got other things to do besides security. I actually want to do something else. He said, okay, that's your choice. I think that you would go blind if you looked at this stuff all day long, and that's really the problem, is that it gets a little overwhelming. So the tool that I suggest is using a protocol analyzer inside of the operating system, communicating with the operating system to get the raw data from the network card. That tool is Wireshark. It's graphical. It can reconstruct streams. It has great filtering features. And there's actually a new tool out there called CloudShark that is browser-based. You can actually do your raw packet captures with PCAP or TCP capture and actually upload them to CloudShark and look at them. And when I have a particular problem, I upload to CloudShark and I get a couple of other people to look at my packets as they're presented inside of that interface. Just like Wireshark, it just happens to be that it's uploaded, and we can discuss it collaboratively. So that's Wireshark, and we're going to dig into how it works in just a minute. Wireshark can't do its job by itself. It needs another tool, and that tool is called WinPCAP. It's a packet capturing monitoring tool. So you've got some layers here, and take a look at these layers before we talk about the diagram down below. So at the bottom here we have network card drivers. That has to be installed by the operating system. That has to work. That could be Ethernet or it could be Wi-Fi. It doesn't matter. And then above that, you've got this abstraction of the operating system, Windows versus Linux. And Windows and Linux treat it very, very differently. Then what you have is an open source library for packet captures, that's WinPCAP, that tells the operating system, give me all this data. And then Wireshark is the application for actually examining this data as it's flowed up to that level. If you don't have a network card, you can't sniff packets. If you've got a network card in an operating system that won't allow you to go into promiscuous mode and it does something else called monitor mode, can't sniff packets. If you don't have WinPCAP, you can't capture those libraries. You can't capture that information in a meaningful way to present to the application layer. Now down below in the diagram, what you see is you've got a packet analyzer. That's Wireshark. That could be anything. Below that, you've got the packet capturing tool, the PCAP, down below, and that's inside the green box and inside the blue box. That gives you a copy of all Ethernet frames from the network operating system. So you're convincing the operating system in something for Windows, it's called TCP sys, I think. You're convincing it to give you a copy of these frames because it normally wouldn't do that. It would say, okay, you need an application here to do this. You're intercepting that instead of going up to the regular browser. You're intercepting those copies of packets and you're flowing them a different way. So you need Wireshark and WinPCAP together to make this work. Let's look inside the Wireshark interface. So when you first launch Wireshark, you won't see any of this, but I wanted to give you an idea of what the interface looks like. At the top, you've got the command menus. You have a blank white box, which is the display filter. We're going to learn a lot about filters, and you need to know how to write filters. Then you've actually got the listing of each one of the packets in that next piece down. There's this kind of 3 layers of looking. That first is all of the packets. The second is one of those packets that's highlighted in the listing packet captures area is then detailed in the details section, and you can click plus and minus on each one of those pieces of the packet itself to examine the details. Down below that is the ASCII and the raw hex. So if we need to go to the hex, we can. It's right here in front of us. That's your basic layout of Wireshark. So how do you make this thing work? Well, first it looks like this blank screen. It's like, there's nothing good for me there. What's going on here? So the first thing you do is you say, okay, I need to capture and I need to set up an interface. So you click on capture and interface, and then it pops up a dialog box like this. You're going to choose a network interface. By the way, looking at this, you'll see that I have 5 interfaces. Now, what you want to do is when you're looking at these interfaces, you go, which one should I choose? So look at the one highlighted in red, and you'll see that it says the wireless Wi-Fi link 4965 AGN, Microsoft Packet Scheduler, and then it says the IP address. But then I want you to look over in that third column. See where it says packets? And you'll notice if you really squint, it's not lit up at this point, but it says 5. All the other ones say 0, and that one says 5. That's the one you want to capture because it's showing you packets. So if you just wait a couple of seconds, you'll see some packet information flowing across, and you'll see that increment, that counter increment. If you don't see anything incrementing at that point, open up a command prompt, ping your local DNS server or your router, and then packets will flow, and you'll see them pop up inside that little piece right there so that you can figure out which interface to choose first. If you're doing this with virtualization, as a penetration tester, remember I said we are going to capture all of our traffic in and out so that we can prove our activity. If that's the case, then you may be doing the virtual VMware adapters. Depending on your operating system, the operating system may stop you from doing that or may ask you, do you really want to turn this particular virtual network card into promiscuous mode? Are we allowed to do that? Again, depends on your operating system. So now you've got 3 buttons there. We're going to focus in on this. So you've got Start, Options, and Details. So we're going to click on the Options button at this point. It pops up the interface for us here. These are your configuration options that you need to pay attention to if you're doing this for a living. If you're just taking a peek and you're playing with Wireshark and you're doing it in your labs, no big deal. But if you don't know how to configure the capture options for your interface in Wireshark, you're going to run into some problems. So first, interface IP address, those things, they're just fine. Buffer size is not a big deal for most of us unless you're on a multi-gigabit backbone. Then you've got some problems with buffering. You can do a capture filter. That means that you will differentiate the packets that are flowing and not take all packets. If you put in a capture filter and you say, well, I want to see more information about the other conversations that were going on at that time, it's too late. You want to apply capture filters very sparingly. The reason why you would do a capture filter is because you know the source and destination of your transmission that you're interested in, and it's a really busy network, and you don't want all that other data. You want to discard that because, remember, you're storing all these packets, and these could get relatively large quick, especially on a busy network of a real enterprise. Notice below we've got capture files. So under the capture filter, we've got capture files, and you can configure the capture files to split into little intervals. You can also say to start captures at a particular time based on a particular amount of data that is flowing. And then you've got all your display options. Now, here's the thing with display options. Busy network. It says update list of packets in real time. In a busy network, if you allow those packets to flow right there and actually examine them, you will overwhelm your Wireshark interface. So what I suggest you do is, if you know what you're doing, deselect that checkbox and then start your capture and let it run. When you're finished, you can go in and examine your packets, and you don't have to worry about the memory being chewed up by the application trying to keep up with the packets that are flowing. Again, if you're playing around, turn it on. If you're not playing around and you know for real I want to capture these packets and I'm not going to look at them until afterward, then turn it off and your machine will run a lot smoother. So now, let's look at an interface where we've got lots and lots of data in it. Up above, what you see is you see color coding for the original list of packets that are there. And then you see a detailed conversation down below in green. That means that it's actually working. And then remember, in the middle there, you've got the expansion buttons. On the left-hand side, you've got the plus and minuses so that you can dig down into more details as you need them. The final pane down below may give you a hint to what's going on. Now, if you squint right now and you look in the blue area at the bottom, what you'll see is in the ASCII decode, you will see that this is a web conversation. And you can tell because it says Gecko Firefox. So you know a lot about the conversation that's going on between these two hosts based on looking at the actual ASCII. Now, if you went up a pane, you would see that it's Ethernet, Internet Transmission Control Protocol, and then it says Hypertext Transfer Protocol. So you could look there and see that you're having an HTTP conversation. If you went up to the pane above, you would also look at the ports that it was using, and that might give you a hint as to an HTTP conversation, or you can actually see on packet 224 that it's actually an HTTP conversation that got set up in the original communications there. Okay, so packet 215 is an HTTP packet. We know that's an HTTP conversation. Then you've got the details of this selected packet and then the raw packet information. So we clicked on that one, packet 215, then we looked at the details, and then we can look at the raw information. We can filter this conversation as it flows and say, just show me inside of this interface only HTTP traffic. How you write that filter is you type in HTTP. Boom. You're done. You have filtered at that moment in time. We're going to look more at filtering options and capturing options in just a minute. I want to give you a couple of rules of Wireshark. These are rules to stop you from hurting yourself. Capture as close to the complaining user or device as possible. That lessens the crap that's flowing across the wire. So get close. Know how to capture the packets before you need to. In other words, learn about spanning and tapping. We'll see that in a second. Know how to capture because it's not an easy thing to make up on the fly. Use capture filters sparingly and display filters liberally. Capture filter means that you won't get the packet later on. It says, I never want that packet. Display filters say, I've got all the packets. I don't want to see all this stuff because I don't want to confuse myself. Build custom profiles, build custom coloring rules, and filters if you're going to do this any more than once. Build what's called a hot trace file library, and that is a set of trace tools that you can filter from. So we'll call them the hot list, and learn that hot list. I put mine on a notepad. You can do it inside of the interface. It'll actually give you a whole bunch of places where you can drop down and say, I want to filter by this, this, and this. I do it in a notepad because that works for me. I have lots and lots of notes along with it. The packets never lie, but they will not tell you why something is happening. You have to know why. In our case, for us, for most of what we're doing, we're either, from an evil side of things, we're either capturing clear text passwords or looking at the communication protocols so that we can break them, or on the other side, we're recording this information so that we can prove to the organization that this is what we did and when we did it and how we did it with packets there. So you've got two different uses for this tool. Lastly, it's not a rule that's on here, but here's my rule. Go to Laurel Chappelle. She actually has written the best book on this. She teaches a really great course on this. I love the book. I want to get the certification, and it's an incredible book, and it's got some great lessons in it. If you're going to do any packet capturing, I would say if you're going to be a penetration tester, the likelihood of you doing packet capturing on a daily basis is pretty high, so you might as well learn that skill. It's like learning how to touch type. It'll make things go faster. So let's look at some of the key tasks that you want to perform, that you want to understand. And again, this is definitely both real-world experience and exam-based experience, so you have to be able to do all these activities. Capture wired traffic and wireless traffic. Understand profiles, hot capture filters and hot display filters, building coloring rules, finding problems using graphs. We'll only touch on that and then the expert. Okay, so wireless traffic captures. You must have a promiscuous monitor mode adapter. If you go to my expanding security site and you type in wireless traffic capture into the search box, you will see the list of appropriate USB wireless cards that you should be interested in purchasing. You want to get one that works for you. I like the Alpha cards because they work across all operating systems and they're very portable. They're also USB based, so I don't have to worry about internal hardware problems. You can also, remember, if it's USB based and you happen to be using virtualization, you can directly connect that USB based tool inside of your virtual machine, subverting the underlying operating system if it's got problems. I'll show you those problems in a minute. Air PCAP adapters are expensive, but they do the job for you all at once. The triple adapter that you can get for about, I think it's like $600, will actually capture all the signal across all of the different interfaces, all of the different channels that are available to you in the US, and then it makes it a little easier on you. It's got an actual couple extra tools inside of it. If you can't afford that and you only got $50, I think the Alpha cards are great. They come in a variety of strengths as far as the transmit and receive is concerned. Okay, so now let's look at this wireless driver issue. If you're using a Linux-based system, you don't have any problems, there's no issues whatsoever. I happen to use a Mac-based system and I use VMware and I put Backtrack inside of my Mac operating system. When I plug in my USB card from the outside and I directly map it to my Backtrack instance of Linux, no problems whatsoever. You could also do the exact same thing for a Microsoft operating system. For Mac, you have to realize the signal's coming through and then you get into what's called monitor mode. Monitor mode and promiscuous mode are two separate things. You're allowed to monitor and then you go into promiscuous mode. That allows you to do capture and display filters. The problem is that monitor mode for the Microsoft operating system does not work the way you want it to. You cannot capture all of the packets that are flowing, especially when it comes to wireless. You cannot capture a lot of the packets. If you want to do packet injection wirelessly, you cannot do it on a Microsoft-based operating system. You've got to choose Mac and you've got to choose Linux. That's the choices here. So look at the wiki on Wireshark.org's Capture Setup Wireless LAN and look at what they have to say there. Also look at what they say in Backtrack on the wireless section there for the network cards, or you can go to my site. Let's talk a little bit about a passive and active sniffing. Most of the time, when we're talking about doing Wireshark captures, we say we need a way to listen to the packets. The way we do that, there's a couple of ways, is we can plug in a hub between two sides. So you've got your inbound and you've got your outbound, and you say, okay, here's my hub here, plug in here, and then pick up the packets. You're going to need to intercept, you're going to need Ethernet cables, and you're going to need the ability to do that. And that might not be possible with your setup or with the network that you're working with. So you might have to work with a tap. Well, I'll show you some taps in just a minute. That's passive sniffing. That's different than active sniffing. What you're saying is the switch is not telling me what I need to know because it's doing its job. So what we can do is we can force the switch to do what we want by doing ARP spoofing, MAC flooding, and MAC duplication. All of those things are basically corrupting the way that the switch works, if the switch will let you, so that you get all of the packets. Now, from an intrusion detection standpoint, this is really, really noisy when you start doing any of these. So if you think you're going to be playing around with ARP spoofing and MAC flooding, it's not going to work. So how does a switch work? Well, its responsibility is to separate collision domains. It does not separate broadcast domains. And it makes all of its decisions based upon the MAC address, not the IP address. It looks at layer 2. it creates a table within that device, and that lists the max on a particular segment. And when I say segment, usually what you think of is port. So that is one segment, and it will say, I'll make my decisions there. It's not very smart, and it will take any new data. What new data? I could say I've changed my MAC address, and it would update that table, unless that was fixed with that port. So what we want to do is we want to figure out another way to do this. We don't want to corrupt the switch, so what we'll do is we'll do port spanning or mirroring. We go to the switch itself and we say, all of the traffic that is flowing across all of these ports, we want you to copy all of that to this port over here and give us all that data. Now, let's talk operations for a second. If you walk into an organization that's got racks and racks of switches, and you walk up to the network administrator and say, I want you to span all of that data of all those 100 megabit ports out that gigabit port, and I want you to shoot all that data to me, they're going to go, no way, because that port, that gigabit port, that uplink port is very expensive and also very important to them. So the likelihood of them doing that for you is kind of low. You could span individual ports out of that and take an extra piece off of it. Again, unless they've got a core switching function that a core switching design that allows them that extra bandwidth to get your packets off so that you can examine them, they're going to push you to the side. What you really need is you need a tap. And there are all different types of taps out here. This is just a short little peek at some that you can also find on the Wireshark site. They'll talk to you about these and try and sell you these. That's their way of making money. Totally respect that. What you do is you put this tap in place between the source and destination. The nice thing about the ones that they offer at the Wireshark site, I think it redirects to a paid site because Wireshark is .org. But the nice thing about these tools that they have there is they are passive. And what that means is that if you go an inbound and an outbound and that device fails and it loses power, it makes the connection again and there's no loss whatsoever. And what we want to do for those network people, those administrators out there, is we want to say, this device is designed so that if it fails open so your stuff keeps on flowing. And it won't interrupt. If my device that I'm plugging in capturing these packets fails, it won't have any effect on what we're doing here whatsoever. Now, depending on the speed of the network and the segment that you're on, you're going to have to buy more expensive taps as you go along. And this is going to be a difficult process to get in place. Some organizations are so tuned into this, they actually have these taps placed well within the network, and they've got a design for this. That's rare, and so you've got to be looking for it, and you've got to be able to communicate. I would suggest that you have some sort of background knowledge in something like Cisco's CCENT or CCNA so that you can communicate with these people, or the Juniper certification so that you can communicate with these people and say, this is what I need. You're a security guy that understands network. You're a security gal that understands the network and can communicate with those people. Now, you can create profiles that are customized preferences that you want. I like Wireshark set up this way. So I want these preferences, I want these captures, I want these display filters, and I want these coloring rules. And so I'm going to create that. I'm going to create this custom profile, and I'm going to name it. And every time I launch Wireshark, I'm going to start it up. If you're doing this, more than once a week, you're going to want your own capture profiles. Let's talk capture filters. Remember, the data flows off the network. The WinPCAP catches it. The capture filter says, I'll only give you a subset of the information that's flowing. And then the capture engine looks at it. So that's capture filters, and we're going to look at the other filters in a minute. We need to dig a little deeper into capturing. Now, there are two kinds of filters. There's the capture filter and there's the display filter. The same thing that you do in a capture filter is the exact same thing you can do in a display filter. But what you want to do is you want to be very careful about your capture filters because they're going to limit data that you'll never be able to reclaim later on. So you want to be careful about these. You may want to say anything to and from this IP address. host. So if you're looking at that server over there, you go, okay, that's the server that I want to do. I know what its IP address is. I don't want to see all the other traffic that's going on between these hosts over here. I just want anything in and out from here. That's what I want. Host. So if you're looking at one, you go, I've got a problem with a particular type of traffic. I know that it's overwhelming the network. Let's say it's a particular port. Port 67. TCP or UDP, you've got to pick. Point is that then you're isolating all your traffic to that particular port. For example, TCP port 80. I only want to see web traffic. To this web server, to that web server, to any web server, from a client to a web server, port 80. Okay, I'm narrowing it down there. Now these last three, I don't think so. Ether host, my MAC. So here's my MAC address, only to this station. Or not to this station. Now that one's a pretty good one. I don't want to be included in the conversation because I'm monitoring, so it really doesn't matter what's happening with me. I don't want that in here because it'll corrupt the capture. That one's not bad. Not me is really a good one. Wireless LAN host. A wireless, if you're in monitor mode, you'll be able to pick up anything on that network card. Again, I don't like that. I like the not me. I think that's a really, really good tool. And I like the port tool. I think that's a good tool. And the host tool. Be really careful with the capture filters because you get to the end of your experiment or you get to the end of whatever you're doing and you go, where's that data? And it's not there. The reason why you do this is because the volume of data flowing in could be on the multi-gigabyte level. Be careful about that. Display filters. Okay, now these go nuts. They're a little bit different in the way that they're set up. Here what we're saying is let's see a whole subnet. Now if you've got access and you can listen to that whole subnet, because remember you've got a span, there it is, /16. That says 10.2.anything, let me hear it. You could invert this. The bang says not this IP address or this range. Don't use not equal. It works, but it has bad results. TCP analysis flags. If you just want to look at the flag systems, suppose somebody's doing a Christmas tree attack or you want to do a Christmas tree attack. You want to do flag analysis. You can get really specific, and these last three down here are very specific. Look at that last one, FTP response argument, an argument within FTP where it says login incorrect. This would tell you people are trying to brute force the server, because it doesn't have a shut off mechanism or basically a block mechanism, and we can see people doing that. You could capture and look for that kind of traffic. Host display filters are an excellent tool. When you find yourself digging through the second pane for more than, say, 5 minutes, you need a filter. You need to turn on and off, on and off, on and off filters, and you're there. You can use coloring rules. I like coloring rules. I like doing my own custom coloring rules. When you get checksum errors, they happen quite often on a busy network. You probably want to disable and want to ignore a type of traffic, but I want it to flow through. I want to know that it's there, but I don't want to look at it. You can actually do black on black. Know what you're doing there. Play with your filters. You start off with a couple sets of basic filters, and you can play and start digging into something that's unique to you, but don't reuse the filters that are already there. As you're going through this, you go, God, I don't know, something's wrong here, and I can't figure it out, and I want an overview of the conversation. Let me back up for a second. Go to the lower left-hand corner of the interface, that would be your lower left-hand corner of your interface, and click the expert button. It'll give you more stats that may help you get where you're going. So always check the expert when you're lost. Let's switch to evil. We've been sniffing, learning how to sniff. We've learned Wireshark, put it in practice with it for a couple of hours. But okay, so now let's think about switching over to the evil side of things. We need to talk about how we can abuse, as a penetration tester, MAC data locally on a host, on a regular Windows host or whatever host it is. They have an ARP cache table. This is a list of MAC addresses that they know about that are mapped to IP addresses locally. That lasts for 600 seconds. This gives you information about hosts that you normally want to talk to so that you don't have to re-resolve MAC to IP with every single conversation. Host computers, well, the router also does this too, has this information in it. So both of them together, we could start playing with them and preying upon them. So we want to figure out how to mess with this. Okay, so let's talk ARP spoofing for a second. We're going to convince a victim to send traffic to an attacker. You would say, normally, good guy, going to this location, okay, that data's flowing across here. So what I will do is I will configure IP forwarding for any traffic from this network to this network. And then what I'll do is I'll send a fake ARP response to a victim. Hey, when you want to get there, remap your default outbound to me. I'm actually the way you want to go. The victim sends the traffic destined for the outside world based on the poisoned ARP table entry. I poisoned him, he sends to me. I now examine the traffic that's sitting right in front of me, and I pass it on to its destination. So I've inserted myself into the conversation. That means that I need physical proximity. I can't do this across the internet yet, not with MAC addresses. So here's what the diagram looks like. Bob's trying to get to Alice. The attacker says, when you want to get to Alice, I'm on your switch, forward your data through me, and then it gets passed back through to Alice. The end. We win. Sort of. Because Alice also is going to respond to Bob. So we need to map on both sides of the conversation. Now, there are controls against this, and know that this has been dampened down at this point with most robust switching networks. So on the switch, you can actually do MAC filtering. The IDS will actually stop this in a lot of cases. Now, this is a bad thing. You can fix the address in the client. You can literally say to the client, a static ARP entry of your router is there. Dangerous thing to do, but sometimes that's appropriate. None of this stuff is good, but it's what people do to protect themselves. Now, if this conversation that was going back and forth between the two of them was encrypted, I could redirect it to myself and not be able to examine it, and I'd pass it on. Could we fake this? And the answer is yes. If we can social engineer the parties on either side just for a moment in time. What sniffing through encryption requires is that you have a base understanding of asymmetric encryption and symmetric encryption and how to take advantage of it. When we talk about SSL and SSH, we're using trusted certificates and public keys. So we talk about that in the cryptology section, but for now what you need to know is that asymmetric keys are about certificates, and those certificates are offered by servers. In a man-in-the-middle attack, if we've got an encryption connection here, what we do is we pretend. So let's pretend that good guy over here wants to go to his bank over here. What we say is redirect traffic through me. Okay, we've got that, and now it's encrypted traffic and it's flowing through me. Now what I want you to do is, you say I want to go to thebank.com, and I say intercept a request for thebank.com and offer them a certificate. They'll set up a session with me and create that encrypted communication here, and then I'll say, hey, I'm that guy over there, offer me a certificate. And we'll set up encrypted communications here. I'll de-encrypt in the center and look at what's going on. How would I do that? Well, it's the same thing that the bank does in an SSL setup in the six steps to SSL, which again, we'll talk about in the cryptology section. But now I had to set up an encrypted session here and an encrypted session here. I can't say I'm going to break the encryption. That's not going to work. So our man-in-the-middle attack lets it look like to the people on both sides that they've got encrypted channels, which they do. It just happens to be they're two different encrypted channels. What I would like to do is resolve inappropriately. I would like to sniff the DNS traffic. Remember, in DNS, we're trying to match a fully qualified domain name to a routable IP address, and that's done by the start of authority in DNS. What we will do is we will spoof that we are the start of authority. How we will do that is we will convince the party to go through us, and we'll say, oh, this is the resolution. Oh, you want DNS resolution for the start of authority? I'm the start of authority. Here, I'll give that back to you. Or what I can say is, I can pretend that the start of authority is responding back to you, but the first response back to you from that start of authority, whatever it is, resolution of DNS to IP address, whatever it is, I can hand it to them if I can beat them there. Think about it. If the good guy on the inside wants to go to somebody all the way across the internet and I'm sitting here and he says, hey, where's my bank? That's going to take a while for it to get out there and come back. Where's my bank? The bank is here. And if I send that first, he holds that. I've poisoned his cache, and now he'll resolve to, well, where I want him to resolve, whatever IP address I choose. I'll have to set this up at first, get it programmed, realize, listen to a little bit of the traffic that's going on here, and then set ourselves up for success in the future. You can't do this all at once. This takes a little bit of patience. So here it is in the diagram. The attacker says to the DNS server, hi, I'm here. The customer says, I'm looking for something. What I've done is I've put it in the fake server, I mean the real server. I've said, attacker here, DNS server, take this resolution. And the customer goes to the wrong site. That means that the DNS server, I would have had to have intercepted the DNS server's request for the start of authority out there. I can either do it to the DNS server if I'm quick, which is unlikely, or I can do it to the customer, which is more likely. I would rather do it to the DNS server because then all other clients of that server now take orders from me. We capture more than just one at a time. So sniffers capture the network traffic. That's what we do. We roll all of that stuff up. We can look at logins and passwords if they're in clear text. If they're not in clear text, then we can redirect through an SSL man-in-the-middle attack to capture that information and re-encrypt it as it goes along. When you view the traffic on switch networks, you've got MAC flooding and ARP spoofing. Those are your two tools that you use. So let's talk about some of the things that you're going to need. Wireshark training. Go to wiresharktraining.com or just wireshark.org. IANA for your protocol numbers, IETF for your RFCs. There's a great Wireshark book out there. It's about a year old. And then if you need trace files to practice with, you can go to pcappernet. So that's sniffing in a nutshell.